Alright, so REF8. So we're going to talk about factoring trinomials once again. Remember, trinomials are a type of polynomial. Trinomials have three terms. That's why they're called trinomials. So polynomials can have anywhere from 2 to however many terms. Trinomials specifically have 3 terms. Now in Algebra 2, we're expected to factor pretty much any type of trinomial that can be factored. So just a review of how this works. The first thing that we need to do is construct an X puzzle. So let's construct an X puzzle. Oh, actually, the very first thing that we need to do is check for a greatest common factor amongst all 3 of these terms. Now I can tell you right now, because 15 is odd and the leading coefficient is 2, there is no GCF between all 3 of these terms. So because of this, we construct an X puzzle with A times C on top. Now remember, we can label these 3 terms as A, B, and C, or these 3 coefficients rather as A, B, and C, and we put whatever A times C is on top. A times C is going to be 2 times 18, that's 36. And then B, the leading coefficient of the middle term, not the leading coefficient, sorry, the coefficient of the middle term. The coefficient of the middle term, B, is going to be 15. So we have the leading coefficient times the last coefficient, gives us 36, and then the middle coefficient goes on the bottom. So now we need to figure out what 2 numbers multiply together to give us 36 and add together to give us 15. So everybody take a second to figure that out. I'm going to go over the answer in a second. So try to figure out what 2 numbers go on the sides of the X puzzle and pause the video, and I will go over this eventually, as in like a couple seconds. So we should get 12 and 3. 12 and 3 are the 2 numbers on the sides. They multiply together to give you 36, and they add together to give you 15. So we can split this middle term here. We can split this middle term, 15x. We can split it up into 2 terms. So we've got 2x squared still. That's our leading term. But we can rewrite plus 15x as plus 12x plus 3x. And then plus 18 on the end. Now from here we have 4 terms, so we can use good old grouping for this. So let's group the first 2 terms together and the last 2 terms together with the sign, and find the GCFs from both of these groups. So take a second, pause the video, find the GCF of this first group, find the GCF of the second group, and then undistribute. So the GCF of the first group is going to be 2x. Again, that's the 2 is the biggest number that goes into both 2 and 12, and x is the common variable. And we don't put x squared because this term doesn't have an x squared. The GCF for the second group is going to be 3. There is no common variable this time because this term at the end doesn't have an x. And 3 is the biggest number that goes into both 3 and 18. So now let's undistribute. We've got 2x times some set of undistributed parentheses. So some remainder here. Plus 3 times some remainder here. And we're hoping that the 2 remainders here are the same. So let's undistribute a 2x from the first group. So we're going to pull out a 2x from both of these terms. When we pull out a 2x from 2x squared, we're going to divide 2x squared by 2x. One of the x's is going to cancel. The 2's are going to cancel. We're just left with a single x. 12x divided by 2x. 12 divided by 2 is 6. The x's cancel out. We're left with 6. All right. We're going to pull out a 3 from both of these last terms. So 3x divided by 3, that's going to just be x. 18 divided by 3 is, of course, 6. And our remainders are, in fact, the same. So because we have the same undistributed parentheses, our final answer is going to be our first factor, which is just our GCFs from both of the groups, times the undistributed parentheses, whatever we got as the remainder. 2x plus 3 and x plus 6. And this is the factored form of what we started with. So this is a lot. This is a lot of steps, but this works for every single trinomial that you can do. However, there are two more types of trinomials that you can do other methods with that are a little bit faster. So there are two more types of trinomials that have easier and faster factoring methods. The first one is called a perfect square trinomial. Now, a perfect square trinomial, or a PST for short, has a specific property. All right, the first term, second term, and third term all follow a specific set of rules. So they're always formatted like this. They're always formatted like this. We can always look at it like a squared, so something squared, plus 2ab plus b squared. So we have two perfect squares on the outside, and the middle term is double what you get by multiplying their square roots. So this is the formula for a PST. This is how you determine if a trinomial is a PST or not. Now in this case, our two perfect squares on the outside are x squared and 9. So A and B are going to be x and 3. So in other words, we can rewrite this like this. Think about it. X squared is x squared, right? That's what a squared is. 6x is 2 times x times 3, right? Where a is x and b is 3, right? 6x is not 2 times x times 3. And then 9 is 3 squared, where again b is 3. So because we have two perfect squares on the outside, and the middle term is double both of their square roots multiplied, so it's double the product of their square roots, we have a perfect square trinomial. We have a perfect square trinomial, and perfect square trinomials can always be factored as a plus b and a plus b. So in this case, this is x plus 3 times x plus 3. And that is it. That is the whole process. Now, there is actually another way that we can write this, and this is the reason why they're called PSTs. We can actually write this whole thing. Because this is the same thing multiplied twice, we can write it like this. These two answers mean the same thing. And in the case of this sample problem here, x squared plus 6x plus 9, we can write our answer as x plus 3 parentheses squared. It means the same thing as x plus 3 times x plus 3. So let's do the second one. All right, first let's check to see if this is actually a perfect square trinomial or not. And again, if it's a perfect square trinomial, you can use this method, or you can still use the XPuzzle method that we used before. It will still work, but this is faster if you see that it is a perfect square trinomial. So let's check to see if it's a perfect square trinomial. All perfect square trinomials can be written as a squared plus 2ab plus b squared. So we have two perfect squares on the outside. That's good. A in this case is going to be x. B in this case is going to be 1 because 1 squared is 1. And so when we take the product of them, we're going to get 1 times x. And when we double it, we do in fact get 2x. So in other words, we can rewrite this as x squared plus 2 times x times 1 plus 1 squared. So we can in fact write this trinomial in the same format as a perfect square trinomial. So again, a in this case is x, b in this case is 1. So our answer would be a plus b times a plus b. In other words, x plus 1 times x plus 1. Or x plus 1 squared. Both of these are valid ways to write the answer. Oops, sorry. I've still got a cough. I'm mostly over the cold now, and I'm going to be back on Wednesday, but I still need to give my voice a little bit more rest, and then I'll be fine. Alright, the last one is the leading coefficient of 1. This one has a much faster method. So, believe it or not, both of these also have a leading coefficient of 1, but the method that I showed here is even faster than what I'm about to do. So if you have a leading coefficient of 1, and remember, a leading coefficient is the coefficient in front of the term that determines what degree the polynomial is. So in this case, that's our x squared term. The coefficient in front of that is 1. So because the leading coefficient is 1, we don't actually have to go through the whole song and dance of this process. We instead can skip a couple of steps. So we're still going to start with an x puzzle. Now, in this case, because a is 1 here, always, because the leading coefficient is 1, a times c is always just going to be c. So we can put 21 on top, and then 10 goes on the bottom. And now take a moment to figure out, take a moment to figure out what two numbers go on the sides of the x, then multiply together to get 21, and add together to get 10. Typically, leading coefficient of 1 x puzzles are going to be more simple as well. That's another benefit of them. Okay, so we should get 7 and 3. So now, instead of splitting the middle term, because the leading coefficient is 1, and this only works when the leading coefficient is 1, we're actually done at this step. And we fill in the two last terms of the two factors with the numbers on the sides of the x puzzle, and we're done. Because the leading coefficient of this polynomial is 1, because the leading coefficient of this trinomial is 1, and this only works when the leading coefficient is 1, we can stop after the x puzzle. We don't have to split the middle term. Can you split the middle term? Yes, you can. If this is hard to remember, you can still do the whole song and dance. This is a universal method. The one that we learned last class is universal for every trinomial. But this only works if the leading coefficient is 1. So now let's do this next one. Let's make an x puzzle. Negative 15 on top, negative 2 on the bottom. Pause and try to figure out what two numbers go on the sides. They multiply together to get negative 15, and they add together to get negative 2. Okay, so we should get negative 5 and positive 3. And because the leading coefficient is 1, here, our answer is going to be x minus 5 and x plus 3. They're just the two numbers on the sides of the x. And that's how you do it. So I want you to work on the sample problems at the back. Now I will warn you, the bottom two, and I know it's really hard to see, the bottom two are curveball problems. The bottom two problems on the back are curveball problems. Alright, the bottom two on the back are curveball problems. And we will be going over them next class, but I do want you to try them, okay? Your homework will be posted in Canvas.